SAS programming challenges in ISS and ISE studies having different units. Now here the studies I will consider A to L, which is 12 studies to be pooled. ISS is integrated summary of safety. ISE is integrated summary of effectiveness and efficacy. SDTM and ADAM data standards wherever relevant. Now the problem here is different formats and different units for lab results and vital signs. Now lab results is always complicated, tedious and a very time consuming kind of piece of work. Whosoever gets this piece of work. The reason is, first of all, you will have too many lab values, especially the lab test, which comes from hematology, biochemistry, then urinary analysis. Some will have serum analysis, then you will have microscopic and other. And on top of that, you will have more central and local results. Now, central is something where you will get the standard units, right? The vendor, whereas the local vendors, what they will do, they will they'll not convert the values and units into the SI or the standard units. They will just collect whichever way, because they don't have any specific SOP or specific standard way to do. So it becomes quite complicated when you get the lab results or the lab data from two different vendors, one from central and one from local, and then you are combining. Now here the question is, we are considering 12 different studies, right? So imagine how much complicated it would be and how much data you will be having. Now the lab units, they differ. Say for example, one specific lab test is in milligole per deciliter, whereas in another study it is millimole per liter. Now some labs recorded as strings, less than 0.01. Now the question here is how to solve this problem when you have different units. Now the solution here is to standardize measurement units to a common target defined per analyte and convert values. Now what you need to do is, like, say for example, I have 12 different studies which I need to pool into one single ISS or ISE study. So here whatever the lab data that you have separate for 12 studies, you need to combine either vertically or horizontally, whichever it is, like just like appending, like combining, now you have combined with respect to having the common variable names and the labels and all that, everything. Now internally, when you combine all these 12 studies either vertically or horizontally, you will find the glucose lab test is having different units. So you need to find out which are the unique lab test and which is the unique units. So based on that criteria, you need to find out the conversion factor from one unit to another. So say it's in a local unit, you need to convert into the standardized unit. So what is the conversion factor? Now this conversion factor, it's very easily available, in Google, or you can find out from the lab um, section of the lab department, and you can also even ask to sponsor as to what conversion factor they would like to prefer. So these are all questions that you can find out the conversion factor. Then next is capture the original. Now original value and unit you should never delete. You keep that variable as it is, whatever it was collected in the data. Create another new variable having the values as the conversion factor. Like say if the specific record is having in standard unit, the conversion factor is not is 0 or it is not applicable. But in for those records where the conversion factor is needed, for those you can put that conversion factor. Then next is you can create another new variable, which is, for example, after multiplying or dividing the conversion factor to the original value, you get the standardized value and the standardized unit. So these variables are the new variables that you're creating. Now that is very essential for the traceability. If you want to cross check from the standardized unit to original unit, it becomes very easy, to cross check for verification or for some other departments. Then you can handle the qualified result, for example, less than or greater than, by separate fields like lab underscore qual. So these are all the ways, how you need to handle. Say for example, here I am having a glucose. In study A it is mg per deciliter, in study F it is millimole per liter. So creatine sometimes it is in millimole per liter. So the steps here is you can create a lab unit underscore map specifying the conversion formula for each analyte. Each analyte is nothing but for each lab test. So you need to combine all the 12 studies either vertically or horizontally, whichever way, like is the correct way to do that. And then you can find out the unique lab test and the unique unit. So based on that you can find out the conversion factor. Then you can apply this conversion and create the original unit, which is in numeric, and the original underscore target. So this is the target that I'm going to convert. So that becomes the variables. Then for the qualifiers you can convert the original to numeric and set the lb1 equal to less than or equal to and record original text. So this is the example where I have explained here, like how to use the conversion factor for each and every analyte. Now, for example, here is a SAS program, a very small, simple if and then do else, like a program here. So, like say if the analyte is glucose, then you can check if the unit is millimole per liter. Then you can create another new variable, right? By converting into the numeric factor, this is the original value which we got from the raw data. So you are converting this into the mg per deciliter. So you use this conversion factor. So here 18.0182 is a conversion factor from millimole per liter to mg per deciliter. And this is the format that you applied, question mark best dot. So in whichever format the value is, when you combine the 12 different studies, you will find different formats, like say some records will be in 0 decimal, some records will be in 1 decimal, some record values will be in say 3 to 4 decimal. So in those scenarios we can use this question mark best dot, so it will automatically use the best value and convert. So this is the conversion factor. Else you can create this into the input, this specific original value as it is, and you don't need the conversion factor. So this is a small SAS hint that you can apply when you see any challenges, like different studies are having different units. Now this is just an example for one lab test. You may have so many different other lab tests, so it's always a tedious and time consuming kind of a job, and a very daunting job when you work especially in labs. Many thanks for watching my video and happy learning. Please like, share, subscribe, leave a feedback comment. Many thanks for your support and having great connection.